steel or low carbon steel. It is malleable, so it can be beaten into sheets. It is ductile. It can be drawn into wires. And mild steel has got a low tensile strength, but it is cheap and therefore easy to form. That's why the use on ship is extensive. Now, for application on shipbuilding, for the construction of hull, mild steel has got 0.15 to 0.23 carbon percentage of carbon. So when this is that amount, the manganese content is high, sulfur and phosphorus content is not more than 0.05% because it can be then easily welded and cut. Because if your sulfur and phosphorus contents are high, then it'll explode or ignite. Now, your other applications of mild steel are your scaffoldings are made of that, your machinery parts, cookware, pipelines, metal gate, fencing, they can all be made with your mild steel. If you see your bilge plating here or engine room bilges, the plating there on the floor, then the angles here, then your girders, the rods, these are all of mild steel. Plus, this metal is very ductile and malleable. So you see the gantry trains also made with mild steel. But the rusting will take very fast, so you have to have two coats of primer here. Here it is used for fencing. It can also be used in forging industry for nuts and bolts. But these nuts and bolts will get corrosion. So that is the reason these can get corroded because it's not coated properly, then it'll get corroded. Now your eye melting scrap is basically this is car bodies are also made with this kind of mild steel. But here the scrap, if you have that content of scrap here, will be about 60-40. If you see the girders and all will be of one, that is malleable steel, but this is not that malleable steel. So the toughness of these car bodies will be less. So this is got melting point of 1600 degrees Celsius. Now we come to medium carbon steel. So medium carbon steel uses less on ships because here the material is quite hard, so the cutting and all becomes difficult. So here it is can be used in crankshaft and engine room or gears, but it can't be used otherwise. Not on deck and all, or not in pump room and all. So the usage is only for engine room, that also crankshaft. So it is here the carbon content is higher than zero point 0.3. So it is 0.31 to zero point 0.6. Manganese content is 0.06 to 1.65. So it is stronger than low carbon steel, but the formation it becomes difficult and cutting becomes difficult. Cutting welding is difficult. For this reason, usage in ships becomes less because you can't form it easily, you can't cut it easily, you can't weld it easily. So you can't have the various parts of the ship made of that. So crankshaft and all, of course, you don't have to cut and make forms. It is made into a shape and then it is fixed. So it is quite often hardened and tempered using heat treatment. For mild steel, you can do heat treatment of tempering, but here it is tempered to make it hard. So this is used for railway tracks. Now, if you see this railway tracks here, this is HMS1. If you sell it in scrap, this is HMS1, which is malleable. So it can just be melting scrap, which can be melted in the furnace. Your mild steel cannot be directly melted in furnaces because it's got mixtures. Here, this doesn't have mixture. It can be made reloadable scrap where you can just melt it in furnace, make another steel part. This is your crankshaft. These are your wheels of your train, which is also made of medium carbon steel. So you can have machinery parts requiring combination of properties. So you have railway tracks, train wheels, crankshaft, and gears. Now the carbon content has been earlier pointed out as 0.3 to 0.6%. This can be heat treated, austenized, and quenched, and tempered. Now these are the properties I'll be doing again. What is austenization, quenching, and tempering? So I think we have left it out in the other class. I'll be doing austenization and quenching. I think that topic is remaining. So after your high tensile steel, I'll come back to that. Medium carbon steel has got low hardenability. You're adding chromium, nickel, and molybdenum so that you improve your heat treating capacity. These alloys are stronger and have low ductility. So your applications are railway wheels and tracks and gears and crankshaft. Now we come to high carbon steel. Now high carbon steel, carbon content is quite high, that is 0.6 to 1%, much more than your medium carbon steel and low carbon steel. Manganese content is 0.3 to zero point 0.9. So these are quite tough. So they can be used for spring or high strength wires or insulation in fire retardant divisions, that is fire bulkheads A and B, or in reefer tanks for insulation. So it's got very good resistance. Wear resistance is good. So it can be used in cutting tools like chisels or high strength wires. And your microstructure is finer and that improves the toughness. So here the hammer head is made of high carbon steel. Ball bearings made of high carbon steel. The chisel, the punches, these are all high carbon steel because this is harder than medium carbon and more brittle, but can be heat treated so that it becomes harder and tougher. Then we come to your high tensile steel, which is used in ships in areas where you have a lot of tensile stress, that is your shear strake, your garble strake, that is all made with high tensile steel. So it can withstand maximum strain without failing or breaking or getting deformed. And the thickness of this plating of high tensile steel will be much less as compared to normal mild steel plating. So it is having yield strength of 50,000 to 1 lakh pounds per square inch. Carbon content is high, that is 0.6 to zero point 0.8. Sulfur content, again, as I said, in all steel, sulfur content is 0.05. Phosphorus content is also 0.05. It cannot be more, otherwise, well, doing cutting and welding will have an explosive content. Manganese is 0.6, silicon is 0.2. Now, the strength of this material is the capacity to oppose force, so weight or stress. So, the strength of mild steel is always less than high tensile steel. So, it's got greater tensile strength for equivalent thickness at low temperatures. So, it is used on large VLCCs or VLOCs, and it is designated by H, letter H. So A is your grade of steel and H is your high tensile steel. It can also be your strake and high tensile steel. So either it can be grade of steel and high tensile steel, or in the shell expansion plan it will be shown as A, H, B, H, C, H. So that will be your various strakes. So AH becomes garboard strake, B becomes the other strake. So it can be, numbering can be either with grades of steel and high tensile steel or strake and high tensile steel. So it is used in mechanical engineering applications like shafts, rotors, wherever your stresses are high, which has got highly stressed or heated conditions. So high tensile steel has got a very high yield point, and it demonstrates a reduced plastic ductility and brittle fracture behavior as compared to mild steel. So this is your high tensile steel. The plates will be thinner as compared to normal MS steel. Now the advantages of high tensile steel, it comes in your exams also. So first advantage is reduced cantlings. That means the sizes of various structural components on the ship is reduced. So when the structure is reduced, your light ship weight is also reduced. So when your light ship's weight is reduced, your dead weight will increase. So your load carrying capacity will increase. So your profitability will increase. It has got greater tensile strength even at low temperatures, and it has got extremely high strength and stiffness. Now the disadvantage of high tensile steel is if corrosion occurs in this, so your reduction in thickness will be more as compared to MS steel, which will make it uh, leaving a weaker than ordinary MS steel plate if it is corroded. So you got to be very careful with the maintenance of these kind of plates. And because you're reducing your scantling, it can be dangerous for the strength of the ship. Plus the high density of the components of steel inside this, the grains of the steel that has got high density and high tensile steel can lead to brittle fracture. So I'll come back to your, I'll not do testing now. We'll be doing your austenite and other behaviors of your steel. I think we have left that. And then we'll come to the testing of steel. Now, steel basically, other than your pig iron, wrought iron, steel, you're adding more of manganese and other materials like chromium and nickel, molybdenum, and all. And addition of carbon to iron forms iron carbide or cementite. So cementite is a configuration or molecular configuration of steel where your molecules are side by side, and they can also be known as pearlite. Now cementite is a compound. I'll just show you compound here. Yeah. So if you see this, the crystal behavior of this rhomboid system, where you can see the various grains of the cementite steel. You see the porousness of the steel here you can see. So this is iron carbide in a compound of iron and carbon with more precisely intermediate transition metal carbide with formula Fe3C. So by weight the carbon is 6.67%, while iron by weight is 93.3%, and the structure, crystal structure is orthorhombic. That means the joint is here, rest or on the side, so orthorhombic crystal structure is there. Now, cementite is thermodynamically unstable and it can be converted to austenite, which is another form of steel, which has got low carbon level, and graphite level, which has got high carbon level at high temperatures. So that conversion levels can be done. So it does not decompose on heating to a temperature which is eutectoid temperature. So eutectoid temperature is also known as critical temperature, after which your structure of steel can change. So it does not decompose on heating to a temperature below eutectoid temperature on metastable iron carbon phase. And this is the eutectoid temperature, the minimum temperature at which your material exists in a single solid solution phase, or when you have an alloying metal elements completely soluble in matrix phase. So that is the eutectoid temperature. Now we'll be doing the eutectoid temperature because the thing is in heat treatment the eutectoid temperatures is important because accordingly your the configuration of molecules will change. The second one is your perlite. That is another structure of iron carbon compound. That is a two-phase lamellar structure. I'll show you this diagram photograph here. So it's got a pearl-like appearance, the steel here. This is after heat treatment, that change is there in this perlite. So you had seen this grain structure in the cementite behavior where the porous structure is there. But in perlite, the pearl-like structure will appear. So this is a two-phase lamellar structure composed of alternating layers of ferrite and cementite that occur in some sheets and cast iron. And during slow cooling of iron carbon alloy, pearlite forms by eutectoid heat reaction as austenite cools below 727 degrees Celsius. So the cooling is slow in this. We'll be doing the different kinds of heat treatment where your cooling is fast, your cooling is slow, and then you're not heating to the eutectoid temperature, heating to maybe half the temperature of that. So the various heat treatments we'll be doing. So your molecular structure is going to change of the grains of the steel. So pearlite is a microstructure occurring in many common grades of steel. So transformation of pearlite to austenite takes place at lower critical temperature of 727 degrees Celsius, and at that temperature pearlite changes to austenite because of nucleation process. So that is the pearl-like appearance of the steel here. The third molecular arrangement is austenite. So that is a gamma phase iron, and that is a metallic, non-metallic, non-magnetic allotrope of iron. So yet this will not be attracted by a magnet or a solid solution of iron with alloying element. So in a plain carbon steel, austenite exists above critical eutectoid temperature of 1000 degrees Kelvin. Other alloys of steel have different eutectoid temperatures. Austenization means to heat that iron-based metal or steel to a temperature at which it changes crystal structure from ferrite to austenite. So if you see this is the structure of ferrite, then the structure changes to austenite in this phase. So we completed that. So you got any questions on these forms of steel, cementite, pearlite, and austenite? Because in heat treatment that changes will take place because of
सब
that
परलाइट
eutectoid.
शिप पे यूज होता
परलाइट देखो ये जब हीट ट्रीटमेंट करने के बाद चेंजेस आ रहे हैं तो हीट ट्रीटमेंट अगर ज़्यादा अभी हम हीट ट्रीटमेंट कराएंगे तो आपके हीट ट्रीटमेंट को डिपेंड करता है कि आप परलाइट यूज़ कर रहे हो कि ऑस्टेनाइट यूज़ कर रहे हो कि सीमेंटाइट यूज़ कर रहे हो. सो इट ऑल डिपेंड्स ऑन विच काइंड ऑफ हीट ट्रीटमेंट यू आर डूइंग, क्योंकि हमारे 4 हीट ट्रीटमेंट हैं. सो यू हैव टेम्परिंग, देन यू हैव 3 और हैं. बताओ भाई कौन कौन से पढ़ाया हुआ है तुम लोगों को, क्या क्या है बताओ.
सर अनिलिंग, टेम्परिंग, हार्डनिंग, नॉर्मलाइजेशन.
हाँ, वेरी गुड. तो हार्डनिंग में क्या है, सडनली आप उसको गर्म करके गर्म करते हो यूटेक्टॉइड टेम्परेचर के ऊपर और सडन कूलिंग कर देते हो तो वो एकदम हार्ड हो जाता है. उसमें कार्बन कंटेंट हाई होना चाहिए, नहीं तो हार्ड नहीं होगा. तो अगर वो कार्बन कंटेंट लो है उसको हार्डनिंग कर ही नहीं सकते. तो ये सब चेंजेस आएंगी आपके चेंज ऑफ योर माइक्रो स्ट्रक्चर ओनली. तो डिपेंड करता है कि किस में आप यूज़ कर रहे हो, कहाँ यूज़ कर रहे हो, उसमें अनिलिंग कर रहे हो कि टेम्परिंग कर रहे हो कि नॉर्मलाइजिंग कर रहे हो, अकॉर्डिंगली आपके स्ट्रक्चर अंदर चेंज होंगे। तो आप नहीं बोल सकते कि शिप पे यूज करते हैं कि नहीं, वो डिपेंड करता है आप कौन सा हीट ट्रीटमेंट यूज कर रहे
ओके सर।
हैं। ओके, अब वी स्टार्ट विद योर, अभी टेस्टिंग ऑफ स्टील तो अभी इस बार एग्जाम में आया था, टेस्टिंग ऑफ स्टील 2 टाइप के टेस्ट के आया था। सो कई बार आता है लिखा हुआ कि ये लिखो, कई बार आता है नहीं, टू डिस्ट्रक्टिव टेस्ट यू कैन मेंशन। सो डिस्ट्रक्टिव टेस्ट का मतलब है कि उसको डिस्ट्रॉय कर देते हैं स्पेसिमेन। आई थिंक आपको वीडियो सब दिखाया हुआ है,
हाँ सर, पहले
क्योंकि अगर
दिखाया हुआ
वीडियो
क्रीप
सारा दिखा,
टेस्ट, फटीग टेस्ट,
ये सब आपको दिखाया
टेंसाइल
हुआ वीडियो, सब दिखाया हुआ वीडियो। तो टेंसाइल टेस्ट में तो आपको बताया था, जब हमने स्ट्रेस स्ट्रेन रिलेशनशिप किया था, उसको खींच रहे हैं ताकि वो ब्रेक पॉइंट पे आए, तो सैंपल तो टूट जाएगा ना, सैंपल खींच के टूट जाएगा। अब
टेस्ट।
जैसे मैं एग्जांपल देता हूँ, मारुति कार है, तो आपके जो कोलिजन वाले जो क्या उसको बोलते हैं, बलून बनते हैं ना, जो आपके कई बार कोलिजन होता है कार में, तो इम्पैक्ट प्रूफ कुशनिंग आती है, वो दे स्वेल अप। तो आपकी लेटेस्ट कार में यह है कि कोलिजन होगा तो वो फूल जाएंगे, और आपके इम्पैक्ट ऑन योर बाय द स्टीयरिंग व्हील एंड
एयर
ऑल
बैग
दैट,
बोल रहे हैं सर आप?
एयर बैग
एयर
जो,
बैग।
हाँ वही कुशनिंग जो है वो, दैट इज एयर बैग्स। एयर बैग्स आप शिप बिल्डिंग में भी यूज करते हो फॉर रिलीजिंग योर शिप ड्राई डॉकिंग के टाइम, वो दैट इज स्लिप वे में एयर बैग्स यूज करते हैं, और यहाँ भी एयर बैग्स यूज करते हैं विच प्रोवाइड यू कुशनिंग। अब जब आप एयर बैग को टेस्ट कर रहे हो, तो सपोज कार का मैन्युफैक्चरर उसको टेस्ट करता है, तो कार को डिस्ट्रॉय करेगा ना, क्या नहीं करेगा? कार को पहले कोलिजन कराएगा, और उसमें डमी रखेगा, और फिर चेक करेगा कि वो एयरबैग फूलता है कि नहीं फूलता है इतनी वेलोसिटी पे। सो दैट इज नोन एज डिस्ट्रक्टिव टेस्ट, यू आर डिस्ट्रॉइंग द कार टू फाइंड द फंक्शन ऑफ दैट स्पेसिमेन। सिमिलरली जैसे होज है, होज टेस्ट हम डिस्ट्रॉय करते हैं 5 गुना ज़्यादा प्रेशर नॉर्मल प्रेशर से डाल के, और उसमें वेरिएशंस करते हैं 200 टाइम्स फ्रॉम जीरो टू दैट मैक्सिमम ट्वाइस दैट ब्रेक वर्किंग लोड, ताकि वो फट जाए। बट उसको हम पोर्ट में नहीं करते, वो अंदर उनका एक सेक्शन होता है जहां टेस्टिंग करते हैं। सो दैट इज नोन एज डिस्ट्रक्टिव टेस्ट। तो आपके एग्जाम में आता है नेम एनी टू डिस्ट्रक्टिव टेस्ट। अब कई बार आप लोगों ने क्या लिखा है, कहाँ से उठा के पता नहीं दे देते हैं, नेट में गूगल में डाल के सर्च करते हैं डिस्ट्रक्टिव टेस्ट, और वो लिख देते हैं, वहां जीरो मिल जाता है। वो सब गूगल में सर्च करने की जरूरत नहीं है, आपको यही 6 में से 2 लिखना है या 3 लिखना। और मैंने उनको पहले भी समझाया था, उन्होंने गूगल से सर्च करके लिखा और फिर जीरो मिल गया, फिर बोलते सर जीरो मिल गया, तो मिलेगा ही भाई। डिस्ट्रक्टिव टेस्ट हमारे लिए ये 6 हैं, उधर से बाहर से कोई नहीं उठा के रखना, गूगल में नहीं करना सर्च। गूगलिंग करोगे तो फिर हमारे से अंडे मिलेंगे, फिर ये ध्यान रखना, यही लिखने हैं।
देसी अंडे
तो
दीजिएगा फिर।
अब फिर वो देसी ही देंगे, फिर विलायती वाले तो, देसी वाले और महंगे हैं भाई, है ना, देसी अंडों की कीमत ज्यादा है एज कम्पेयर टू विलायती अंडा।
बिल्कुल।
अच्छा, अब ये देखो, टेंसाइल टेस्ट आ गया, बेंड टेस्ट आ गया, हार्डनेस टेस्ट आ गया, इम्पैक्ट टेस्ट आ गया, क्रीप टेस्ट आ गया, फटीग टेस्ट आ गया। अब आपको याद करना है तो एक लेटर बना सकते हो, क्या लेटर बनाओगे? है, कोई भी लेटर बना देना। हिट बना दिया, HIT हिट, और BCF कर दिया। हिट BCF बनाया तो 6 के 6 याद हो जाएंगे। कुछ भी बना दो निमोनिक्स में याद
यस।
करने के लिए, कोई वर्ड बना दो याद करने के लिए। क्योंकि फिर उस टाइम क्या है कि जैसे जैसे एज हो जाती है ना भाई, याददाश्त कमजोर होनी शुरू हो जाती है, तो निमोनिक्स का काम बहुत जरूरी है। हम लोग हमारे टाइम में तो याददाश्त एकदम खत्म ही हो जाती है। अब आता है टेंसाइल टेस्ट, डिस्ट्रक्टिव टेस्ट। तो इसमें आप टेंसाइल मशीन में खींचोगे, सो हाइड्रोलिक मशीन है, यू गोइंग टू पुल इट वर्टिकली और हॉरिजॉन्टली। दिखा दे मशीन आपको, ये मशीन है, तो ये वर्टिकल पुल कर रही है, तो इसमें आप पुल करते हो तो इसमें इलोंगेशन हो जाता है, फिर यहाँ नेकिंग होती है, और नेकिंग के बाद ब्रेक पॉइंट आता है, ये ब्रेक हो जाती है और फेल्स। तो ये जो फेज है ये नेकिंग वाला दिखाया है, इसमें नेक बन जाता है। तो कोई भी स्पेसिमेन लगाया, एक रॉड डाली, फिर हमने पुल किया तो एक नेक फॉर्म हो जाता है। देन उसके बाद वो नेक में आपका बीच में वॉइड्स आ जाते हैं, वॉइड्स फिर कोलेस करते हैं, फिर नेकिंग होती है, फिर ब्रेक पे जाता है, जो आपको बताया था ब्रिटल आपको डक्टाइल फ्रैक्चर में। सो टेंसाइल टेस्ट में डक्टाइल फ्रैक्चर होता है, ब्रिटल फ्रैक्चर नहीं होता। So it is carried out in tensile test machine. Load is applied hydraulically to draw up at the ends of test piece. So this is a destructive test. So you can find out your elongation, yield point, limits of proportionality, UTS, and failing point. So your tensile strength is maximum load upon original cross-section area of the material which you are testing. अब ये डायग्राम बनाना जरूरी है, क्योंकि इस बार जो टेस्ट आया था लोगों ने डायग्राम नहीं बनाया तो उनके नंबर कट गए। एग्जाम में लिखा होता है शॉर्ट नोट, बट शॉर्ट नोट का मतलब नहीं कि 4 लाइन लिख दिया छोड़ दिया, फिर 4 लाइन के हिसाब से आपको मार्क्स मिलेंगे। ड्राइंग नहीं बनाई, हिसाब कट जाएंगे आपके मार्क्स। तो ड्राइंग जरूरी बनाओ, टेस्ट में तो सारे टेस्ट में ड्राइंग आएगी। अब ये जो एरिया है अगर इसको वर्टिकल कर दो, नीचे का पोर्शन ये वाला हो गया, ऐसा ग्रिप एरिया, और ऊपर का पोर्शन आ गया ये वाला। ओवरऑल लेंथ इसकी ये आ गई। जिस पॉइंट से वो पतला हो गया उसको डिस्टेंस बिटवीन शोल्डर कह दिया। गैग लेंथ है जहां बोथ साइड्स आर पैरेलल एंड नॉन नेकिंग होगी, तो बोथ साइड्स आर पैरेलल, वो गैग लेंथ है। जहां से आपका रिड्यूस हो रहा है सेक्शन तो रिड्यूस सेक्शन बोल दिया, और ये जहां से वो कर्वेचर शुरू हुआ दैट इज डिस्टेंस बिटवीन शोल्डर। And this is the width of the grip section, the cross section area यहीं से आएगा। And this is the length overall. So this you have to draw for the tensile test. ये भी बना दो तो ठीक है, नहीं तो कम से कम ये तो बना दो। दूसरा आता है टेस्ट इज नोन एज बेंड टेस्ट और डिस्ट्रक्टिव टेस्ट। बेंड टेस्ट में ये डायग्राम पहले दिखाएं। बेंड टेस्ट में ये रॉड है ऑफ लेंथ कैपिटल एल, और यहाँ एक हमने सपोर्ट, ये दो सपोर्ट्स रखा, इसको शोल्डर कहते हैं, और यहाँ एक जिसको प्रेसिंग पॉइंट बनाया है जिसको हम कहते हैं मैंड्रिल। और सपोज एक रॉड है जो इसको प्रेस कर रही है यहाँ से नीचे इस तरफ, परपेंडिकुलरली प्रेस कर रही है और इस पे सपोर्ट कर रहा है ताकि यहाँ बेंड हो, इसको हम कहते हैं मैंड्रिल। So the diameter of that mandrel is D. Area of cross section of the rod is A. Distance between the supports is shoulders, or distance between shoulders, that is your L, small l. So इसको अगर हमने प्रेस करना शुरू किया तो रॉड ऐसे बेंड हो जाएगी। अब क्या है कि हम इंस्पेक्ट करेंगे इस तरफ विथ योर under microscope or magnifying glasses and all that, we'll see कि यहाँ क्रैक तो नहीं हुआ है। कितना बेंड करने के बाद क्रैक आएगा that we check. So ये जो A है that is angle of bend, क्योंकि ये इनिशियल एंगल और ये फाइनल एंगल है, इसके बीच का डिस्टेंस कितना हो गया that is angle of bend. So these are diameter of mandrel, जिसके जो प्रेस कर रहा है, ये दो सपोर्ट हैं जिनके बीच का डिस्टेंस L है, ये क्रॉस सेक्शन एरिया है, एंड दिस अल्फा इज योर एंगल ऑफ बेंड। ये डायग्राम समझ आ गया? देन वी विल डू द थ्योरी।
यस सर।
ओके, बट डायग्राम बनाना है। सो टेस्ट बार और प्लेट इज बेंड थ्रू 180 डिग्रीज। अगर पहले ही क्रैक आ गया तो फिर इसकी बेंडिंग में गड़बड़ है, तो इसको डिस्कार्ड करना पड़ेगा, देन यू कांट यूज दिस मटेरियल टिल द एंड्स आर पैरेलल। इसका मतलब ये ट्राइंग टू मेक दिस एंड दिस पैरेलल टू ईच अदर। और किस पॉइंट पे आपका क्रैक आएगा, अगर वो हो जाता है दैट मीन्स you can use it for bending, otherwise you have to discard that material. So this is to determine your ductility and soundness of material. the bend strength, fracture strength, and resistance to fracture. And these characteristics can be used to determine whether a material will fail under pressure or in any construction process that involve ductile material loaded with bending forces. So अगर वो पहले फ्रैक्चर हो जाता है then you have to discard that metal, और पूरा बेंड होने के बाद भी हल्का सा क्रैक आता है, so that means you can still use that material. Now the third test is your hardness test. हार्डनेस टेस्ट में अगर हम किसी चीज को, जैसे आप कार के बोनेट पे हाथ लगा के कंटिन्यूस प्रेशर रखते हैं, उसके अंदर डेंट हो जाता है, तो दैट मीन्स हार्डनेस टेस्ट उसमें, वो हार्डनेस टेस्ट में फेल हो गया क्योंकि उसकी कार की बॉडी में डेंट हो गया, हाथ ऊपर रखा और वो डेंट हो गया. सो इसमें अब आपको डायग्राम दिखाते हैं. सो सपोज दिस इज योर स्टील मटेरियल जिसके ऊपर एक हार्डन स्टील बॉडी, ये कार्बाइड स्टील का होता है, दिस वेरी हार्ड. सो दिस मटेरियल कैन नॉट बी टफर देन दिस. This material will be softer than this, cannot be hard like this. तो आप जिससे प्रेस कर रहे हो, एक सपोज बॉल बेरिंग है, मोटा बॉल बेरिंग, उससे प्रेस कर रहे हो, so this is known as indenter and the diameter of this is known as D, capital D. अब अगर इस पे आपने इंडेंटेशन किया तो एक गड्ढा सा बन जाएगा and that is known as indentation जिसका diameter है D1. अगर ये soft material है तो D1 will be larger than D. अगर this is hard material then D1 will be smaller than D. That means the indentation diameter will be smaller than the indenter diameter in case of hard metal. But the force has to be continuous, maybe for at least 1 minute, 30 seconds to 1 minute. Force आप लगा के रखोगे, सडन नहीं मारोगे, एक कांस्टेंट फोर्स होगा which will be put for checking the hardness. So constant load is applied to dent the surface of metal and you determine your ability to withstand wear and tear. So you measure it with Brile number, which is indicator of hardness, and that is equal to load in newtons because you're putting a force, constant force, divided by area of indentation in millimeter square. So you'll not have a very large indentation here because you're going to measure it by microscope, so it'll be in millimeter square. ये डायग्राम आपको बनाना होगा. So Brinell hardness test method consists of indenting the test material. कहाँ से टाइम हुआ? 32 हुआ है, 45 पे टाइम होता है.
नहीं तो 45 पे क्लास स्टार्ट होगा ना सर हम लोग का नेक्स्ट.
अच्छा अच्छा, हाँ सॉरी मैं भूल गया था. ठीक है, ओके.
नहीं सर अभी चलेगा सर, 10 मिनट और. सॉरी,
तो ये ऐसे ही बोलता रहता है. मैं भूल गया, मैं टाइम क्या बोल रहा है मुझे यार. 1:45 तक है लंच का टाइम है. 45 मिनट, आधा घंटा, 1 घंटे का नहीं है लंच. ठीक है आप लोग बता. अच्छा ये बोलो ना भूख लग गई है, तो मैं वीडियो लगा देता हूँ. भूख लग गई है तो फिर आप अपना लंच शुरू कर दो. ठीक है, यहाँ तक छोड़ दें. अरे भाई यहाँ तो खत्म करें यार, आधा स्लाइड खत्म करके ये खत्म फिर एक वीडियो लगा देता. ये वीडियो लगाते फिर आप अपना जो खाना पीना करो यार. हम भी अपना सैलड खाएंगे, तुम भी ये खाओ यार. ओके. So Brinell hardness जो है, it is consisting of indenting the test material with 10 mm diameter hardened steel or carbide ball subjected to load of 3000 kg. Softer material में load को reduce करके 1500 kg or 500 kg पे आ जाएगा, and because otherwise excessive indentation आएगा. And the load is applied normally for continuous 10 to 15 seconds in case of iron and steel, and 30 seconds in case of any other metal. Then the diameter of indentation left in the test material is measured by a low-powered microscope. Then the Brile hardness number is calculated by dividing load applied by the surface area of indentation. ठीक है. E. तो 5 मिनट में हो जाएगा. Now grade A steel जो है that has got carbon 0.21%, manganese is 2.5%, silicon 0.5, phosphorus and sulfur is less than 0.05%. Actually, this has to be less than 0.05% because otherwise explosion take place. You can't do welding and cutting then. Then your aluminum is not there. UTS is 400 to 520. Yield strength is 235 and elongation is 22%. Now high grade, high tensile steel जब लिखते हैं AH, H is your high tensile steel and A is your grade A steel. So AH stands for high tensile steel of grade A. So it should be noted that grade A steel temperature for impact test is not applicable. And grade AH में impact test is done at 0 degree Celsius. A में नहीं होगा, AH में impact test होगा at 0 degree Celsius. So that is mild steel used for ship structures less than 20 mm, like your bulkheads, tank top, non-strain decks and superstructure. That is grade A. Grade B is 0.21% carbon, manganese is 0.8%, silicon is same like grade A, percentage phosphorus and sulfur is same like grade A, and rest all is same like grade A, except the temperature at which impact test is done is 0 degrees like AH, not A. A में तो होता ही नहीं impact test. So this is your B grade steel or grade B steel. Grade D steel जो है that is for when you're going to polar regions or where your stresses are high. So this is carbon is same 0.21. Now manganese is 0.6 instead of 0.8. Silicon is 0.1 to 0.35. Phosphorus, sulfur is same. Now there's an introduction of aluminum there. So that's 0.015%. UTS yield strength percentage elongation is same. Impact test is done at -20. Now this is done at much lower temperature than B, which is at 0. So this is used in areas whereas you go subjected to low temperatures, and UTS here is 435 to 510. And the Chapi test can be done at -55 also. That is for, so -20 to -55 Chapi test, impact test is done. So this is used for icebreakers. So this is notch tough steel to resist your cracks, and it's used for structure greater than 25 mm thick. Now grade E steel, impact test is done on -40 to -55, and carbon now is reduced to 0.18, manganese is 0.7, rest silicon, phosphorus, sulfur is same, aluminum is not there, and rest all is same. Temperature at which impact test is on -40 to -55. So this is extra notch tough steel, that is heat treated D grade steel for very thick plating of excess of 50 mm. So this is used for areas which have got very high stress, like your shear strake, bill strake, keels. So whichever are at distance from the neutral axis, maximum distance from neutral axis, that is your shear strake, bill strake and keel. So because you had to understand, because we have done midship sections where all your grades of steel are marked. So I said we'll finish off this. Now your request has come for test. You do want to do test or heat treatment? क्या करना है?
Sir,
टेस्ट
test,
करने
sir.
6 के 6 टेस्ट
Sir, yes, sir,
ओके
test.
ओके टेस्ट कर रहा है. तो पहला आपका टेस्ट हो गया टेंसाइल टेस्ट. So tensile test में you got a load where you are applying hydraulics like this, which I told you. You're pulling this, and here your necking will take place because this is ductile. So your tensile test is there. You have to make this diagram. एटलीस्ट दिस डायग्राम एंड दिस डायग्राम बना सकते हो, नहीं तो यही बना दो. So this is to determine your elongation, yield point, limits of proportionality, UTS. So your tensile stress strength is maximum load per original cross-sectional area. So you have to make this diagram, the width of grip sections, distance between shoulders, gag length, reduce sections, length overall. ये diagram आपको बनाना है. Next test is your bend test. When you're bending the pipes, ये जो bending कर रहे हैं, this diagram is to be made. Here you have a mandrel. That is a support for bending this pipe. These are the shoulders or the supports, and this is pressing down here. So this is pressing down here so that the pipe is bent. So it is trying to bend to parallel region so that the cracks can be inspected here. यहाँ का crack देखते हैं, तो इसको try करते हैं bend करने के लिए so that both sides are parallel. So alpha is your angle of bend. D is your diameter of the mandrel. This is mandrel. These are your supports or shoulders. And L, small l, is the distance between the support. And this is your diameter of the thickness of the test material. So this is the OD of this pipe. So this is the bend test. And while bending, you'll see the cracks here. कितने angle of bend में crack हो जाता है, so you know how much you can bend this. So test bar or plate is bent through 180 degrees, so the ends are parallel. Bend areas are closely inspected for cracks. So you check your ductility, soundness of material, bend strength, fracture strength, and resistance to fracture. And you'll see at what bend, at what angle will it fail under pressure and bend, so that you accordingly use the ductile material. That's the bend test. Third destructive test is your hardness test. So hardness test, you have a carbide steel ball, which is very hard steel ball, and that is known as the indenter. So that is pressed at a constant force on the test piece, maybe for 30 seconds. This is pressed continuously, and then this is removed, and then they check with the microscope about the indentation diameter. If the indentation is more than the indenter diameter, that means this is soft. If the indentation is less than the diameter of indenter, that means the material is very hard. So the diameter of indentation is D1 here. If D1 is less than D, that means the material is very hard. If D1 is more than D, that means the material is soft. So load is applied to dent the surface, and this is measured as Bryant number. That is load in Newton by area of indentation in millimeter square, and that's measured by the microscope. This video I had shown you. So it consists of indenting a test material with 10 mm diameter hardened steel or carbide ball subjected load of 3000 kgs. Softer material, the load can be reduced to 1500 or 500 kgs to avoid excessive indentation. So that's applied for 10 to 15 seconds for iron and steel, and 30 seconds for other metals. So diameter of indentation is checked with a low powered microscope. So Bryant hardness number is calculated by dividing the load by the surface area in mm of the indentation. Now the fourth test is your impact test, or the Chappie V-notch test. This is the diagram we have to make. So here this is the pendulum, the hammer here, and potential energy of this pendulum is converted to kinetic energy, and then it strikes here. So potential energy is mgh. So more the height, the more potential energy is there, and that is converted to kinetic energy half mv square. So once it release, this will gather that velocity. We will not go into the specific what is the velocity, because वो question नहीं है आपका. आपका सिर्फ यही है कि potential energy is converted to kinetic energy, hits the specimen, and there's a notch made in the opposite direction of the test piece, और यहाँ hit करता है, and then it will swing out. So then they check for the crack. अगर वो crack नहीं हुआ तो और ऊपर उठाते हैं. So the angle of the height of the pendulum is raised further and then it is hit here. So this is known as Charpy V notch. We are making a V notch of standard size on the various metals. So this is a striker is there at the end of pendulum which breaks the specimen or creates a crack. This determines your toughness of the material, because hardness is basically constant pressing and this is sudden impact. So what is the ability of the metal to withstand fracture under shock loads? So your standardized high strain rate test is determining the amount of energy absorbed during fracture. So amount of energy is the area under the stress strain curve which we had talked about when we had done stress strain. So the absorbed energy is a measure of the notch toughness of the material. So the pendulum of known mass and length has dropped from a known height, and the energy is transferred to material is comparing your difference in height before hitting and after hitting, how much height it will go. So that is that energy which is transferred to the test piece, and that will create the crack. So notch is to be of regular dimensions and geometry. The last, this there's a creep test. The fifth test is your creep test, and in the creep test, you're having a tensile load at constant tensile load, but the difference is it is kept in your furnace or under high temperature. So the deep load is applied, the strain is plotted with time, and the test results in rupture, which is creep failure. So this is your temperature in the furnace. The tensile load is applied. Now in this you have primary, secondary and tertiary creep. So primary creep is when your slope is decreasing with time. Secondary is, creep is when this is constant slope, and tertiary is when your slope is increasing with time, and then you'll have your rupture here. So this diagram also you have to make in the creep plus this diagram. दोनों diagram बनाने. So creep is a deformation at constant stress, and the creep rates are evaluating material for boilers, gas turbines, jet engines, ovens, and involves high temperature under load or constant load. So you have to determine the behavior of material in designing the failure resistant system. So constant load is maintained at constant temperature. Your temperature is also constant but high. So this is a high constant temperature, and the load also is constant. And then you measure the strain. So you have stage 1, stage 2, stage 3. And stage 1 is decreasing, stage 2 is steady, and stage 3 is increasing. Right. So there you'll have necking, and then internal voiding, and the fracture. So this becomes a ductile fracture, but this is under high temperature. That's why it is creep. Last is your fatigue test. In your fatigue test, you are subjecting the material to alternating stresses, and you have to see how many alterations or how many cycles will the material break. So first you are compressing, and then the tensile, then the compress, then the tensile. So after how many alternating stress will the material break? So here you have to see that because the vessel is subjected to hog and sag repeatedly by the weights and the waves. So that is static and dynamic stresses. So after how many compressive and rarefaction stresses, or how many hog and sags will the vessel break? That steel will break. So the specimen is subjected to number of alternating stresses, and this determines the ability of the metal to withstand repeated alternating stresses, and so you can generate a fatigue life, crack growth rate, and identify critical locations and check what kind of fatigue can set in. Initially, incidentally, the fatigue testing कब होता है? चलो मेरा एक क्वेश्चन है, कौन से जो पीरियोडिक टेस्ट में, कौन से जो सर्वेज में आपका फटीग मेजरमेंट होता है, आप बताओ। फटीग मेजरमेंट, देखो मैं आपको ऑप्शन दे रहा हूँ 3 4 दे रहा हूँ, उसमें से आप सिलेक्ट करो। रिन्यूअल सर्वे, ठीक है, कैस, कैप, ईएसपी, किसमें फटीग का मेजरमेंट्स होता है? 4 ऑप्शन दिए। रिन्यूअल सर्वे,
सर ईएसपी में
ESP, यूनिफॉर्म मेजरमेंट थिकनेस।
एक और है, एक और है, मैंने 4 दिए उसमें से 2 है, ईएसपी तो ठीक है, एक और मैंने कहा रिन्यूअल, कैश, कैप एंड ईएसपी। अब इसमें से 2 कौन से? एक तो आपने बोल दी ईएसपी, अब दूसरा कौन सा है? अभी ओरल में पूछ लेंगे तो क्या करोगे? ओरल में तो चॉइस भी नहीं देंगे, मैंने तो चॉइस भी दिया है। ओरल में पूछते हैं, आप लोग तो पूछेंगे ही, चीफ ऑफिसर बन रहे हो भाई, बताओ।
सर कैश
चलो
होगा
बता
सर।
देते, नहीं, कैप है। कैश जो है वो मैंडेटरी है, कैप इज वॉलेंट्री। कैश में फटीग नहीं मेजर होता, लेकिन कैप में फटीग मेजरमेंट होता है स्पेसिफिकली। देखना है आपको पीपीटी उसका, छोड़ दें, देखना है, चलो दिखा देते, 2 मिनट में दिखा देते। मुझे पता है ये सब आपको पता नहीं है, लेकिन मैं सेकंड मेट्स को पढ़ाता हूँ, इसलिए मैंने कहा आप लोगों को पूछूंगा आपको कितना पता है। पता लगा नहीं पता है, तो इसमें आपके फटीग मेजरमेंट्स होते हैं, क्रिटिकल एरियाज आते हैं, एक्सटेंट ऑफ वाइड स्प्रेड फटीग डैमेज आता है, तो ये आपके स्पेसिमेन पे लोड ऑल्टरनेटिंग स्ट्रेस पे होते हैं। तो अब आप हीट ट्रीटमेंट नहीं कराते, आपको कैश कैप दिखा देते हैं, ठीक है। ईएसपी में तो होता ही है। अच्छा, ईएसपी कौन बना के देता है? हु मेक्स ईएसपी? ये मेरा क्वेश्चन है कि ईएसपी बनाता कौन है?
सर फ्लैग स्टेट।
फ्लैग स्टेट तो बनाता है, लेकिन रिकमेंडेशन कौन देगा? तभी फ्लैग स्टेट बनाएगा ना। शिप ओनर को बना के देना है फ्लैग स्टेट अप्रूवल के लिए।
शिप ओनर नोटिस देता है
यस सर, शिप ओनर को।
हाँ ठीक है, फ्लैग स्टेट नहीं बनाता है। एनहांस सर्वे प्रोग्राम में शिप को करवाना है, तो वो बना के देगा फ्लैग स्टेट को, वो और फ्लैग स्टेट देगा क्लास को। ये डिस्कशन होने के बाद वो बना के देंगे ना, अकॉर्डिंगली वो करेंगे। फ्लैग स्टेट बना के नहीं देता है। और इसी टाइप के अंदर से क्वेश्चन पूछे जाते हैं, पूछते हैं कि नहीं? इस तरह से क्वेश्चन पूछते हैं कि नहीं पूछते? आस्क यू फ्रॉम इन बिटवीन, ये नहीं कि आपको एक पूरा ये टॉपिक बताओ, ऐसा तो कोई नहीं बोलता है। एक जरा ये पहले आपको चार्ट दिखा दें, बड़ा जरूरी है आपके ओरल्स के लिए, तो आप स्क्रीनशॉट भी ले सकते हो इसमें। अब ये कई बार इसी के अंदर से क्वेश्चन पूछ लेते हैं। देखो आईएलओ आईएमओ के कन्वेंशंस हैं, स्टैट्यूटरी क्लास के आपके ये सारे इन कंजंक्शन विद क्लास है, along with your safety equipment, safety construction, radio, load line, MAPOL and all ISM, ISPS, सारे शिप टाइप्स के लिए। लेकिन और इनके बेसिस पे कैश मैंडेटरी होता है, बिकॉज दैट इज ऑल्सो रिक्वायर्ड बाय योर इंश्योरेंस कंपनी, तो ईएसपी भी इंश्योरेंस कंपनी के लिए जरूरी है. तो कैश becomes mandatory for oil tanker. ESP is required for, ESP code is for oil tankers and bulk carriers. लेकिन ऑयल मेजर्स एंड इकोनॉमिक इंसेंटिव्स के लिए शिप ओनर्स फॉर योर कमर्शियल रिक्वायरमेंट फॉर वेटिंग CDIs, सायर, ऑयल मेजर्स एंड ऑल, दे रिक्वायर कैप. तो कैप कैन बी कंडीशन असेसमेंट प्रोग्राम, कैन बी मशीनरी, हल, कार्गो ऑपरेशन मैनेजमेंट. That is, can be for tankers, chemical tanker, gas carrier and bulk carriers. So this will require fatigue assessment also. इसमें नहीं हो, कैश में नहीं हो. तो ये कैश है. और चलो आपसे ये क्वेश्चन पूछते हैं कि ये चीज क्या है, ये जो प्लेट बनी है इसको क्या कहते हैं. अब आपको सेकंड में, आपको तो पढ़ा दिया है मिडशिप सेक्शन, तो इसको क्या कहते हैं, व्हाट इज दिस. टैंक में ये क्या है, ये क्या है, क्या है ये. चलो आप लोगों को मालूम ही
सर
नहीं क्या
स्ट्रिंजर
बोला.
प्लेट.
करेक्ट, स्ट्रिंजर प्लेट. पता, इतनी बार बताया है तो पता होना चाहिए, स्ट्रिंजर प्लेट है. ठीक है, बता रहे हैं, दिखा रहे हैं एक्चुअली, तो यही चीज है. सो कैश जो है दैट इज फॉर योर रेट कोटिंग. आपकी कोटिंग कैसी है, अब जैसे यहाँ कोटिंग्स कितनी गई है, तो आपकी क्लोजली मॉनिटर करते हैं कि टैंक्स में कोटिंग कितनी तरह से गई, कोरोजन एरियाज क्या है, एनोड्स का कंडीशन क्या है. दैट इज एप्लीकेबल फॉर ऑयल टैंकर्स 5000 डेड वेट एंड अबव ऑफ 15 years एंड ओवर, एंड अकॉर्डिंगली इनके ऊपर होता है. ये सब आप लोग ओरल्स में पढ़ लेना क्या क्या है, किसके ऊपर होता है, क्रूड ऑयल कैरी करने की डेंसिटी क्या है, ये आप अपने कैश में पढ़ लेना. इसकी वैलिडिटी 5.5 years है, एंड दिस इज कैरिड आउट विद क्लास रिन्यूअल और इंटरमीडिएट. तो हार्मोनाइज किया जाता है. कैप इज नॉट हार्मोनाइज्ड, बट कैश इज हार्मोनाइज्ड विद योर रिन्यूअल और इंटरमीडिएट सर्वे. So it covers your hull structure, coating of your tanks, and your close-up is there for all ballast tank. Minimum close-up for one cargo tank and 30% of other areas, not close-up. So validity of thickness is 18 months, inspection is 18 months. CAP basically is a voluntary service offered by IACS, and there is no harmonization of CAP. And CAP requires fatigue assessment. ये important है यहीं. CAS will not require, CAP requires fatigue assessment, and there is no harmonization of CAP programs with other surveys. So this is required by oil major. You will check your rate, steel condition, corrosion area, anodes, applicable for more than 15 years of age, about 20,000, and validity for oil majors normally 2 to 3 years. So this is your cap going on. अब ये चीज क्या है, चलो आपको पढ़ा दिया. ये क्या है, what is this, इसको क्या कहते हैं. बेटा अगर आप सेकंड मिड जाओगे, फिर आपको अंदर का स्ट्रक्चर नहीं पता होगा, वहां डेंट हो गया तो क्या लिखोगे. सेकंड इंजीनियर को बुलाओगे, चीफ इंजीनियर को बुलाओगे पूछने के लिए क्या चीज है सर, या मास्टर को बुलाओगे, क्या है ये. आप लोग तो कान खींच नहीं सकता, लेकिन कम से पूछ तो सकता हूँ क्या है. एफ से होता है, इसको क्या कहते हैं यार. मिडशिप सेक्शन दिखा दिया, वीडियो दिखा दिया, इसको क्या कहते हैं. एफ से होता है, साइड में होता है, हल पे होता है, अंदर में होता है
फ्रेम सर.
हाँ फ्रेम. यार देखो, एक स्ट्रक्चर बड़ा मुश्किल से आपके दिमाग में घुसता है. फ्रेम है, करेक्ट. Inspection carried out along with class renewal covers your cap, hull and cap machinery and cargo system, and आपके cargo tanks, coating, strength, ये पूरा चेक होता है. Close-up examination क्या होता है, what is close-up examination, ये पता है. चलो, what is close-up examination.
सर वो हैंड
close-up होता है.
में होना चाहिए एग्जामिनेशन विजुअली.
वेरी गुड. जो आपके हाथ से टच हो जाए, whatever you can touch from your hand and feel, not that you see from a drone or you take photograph, it is close up. मैंने किया था, And incidentally I was a master and मैंने नया कमांड लिया था और मुझे लगाया गया था for close-up survey with another sailing master. We were doing during sailing, टैंक में पानी भर लिया था पूरा टैंकर में, सेंटर टैंक. And I had gone with 2 special surveyors क्लास के for close-up survey in the tank. उसमें हमने राफ्टिंग की थी. तो अंदर में राफ्ट के साथ लाइंस लगाई थी और बाहर से लोग उसको ऑब्जर्व कर रहे थे. हम लोग अंदर जाके फोटोग्राफी की थी. देन वी केप्ट डीबलास्टिंग धीरे धीरे नीचे एंड वी केप्ट डूइंग क्लोज अप सर्वे ऑफ द सेंटर टैंक. तो दैट वाज रिक्वायर्ड बिकॉज 10 ईयरली सर्वे था, उसमें सब कुछ करना था. तो दे अवॉइडेड योर ड्राई डॉकिंग फॉर दिस. उन्होंने सेलिंग में ही कर लिया एंड दे सेव लॉट ऑफ मनी इन दैट. Because I was new master, so I agreed. पुराना master agree नहीं करता. So minimum completed close up of at least 1/3 of cargo tank. अगर मैं orals लेता तो मैं close up के ऊपर बहुत ज़्यादा questions पूछ सकता था. ये practical experience है. Validity of thickness 12 months, inspection time 6 months. चलो अभी आपके और कोई question है तो पूछो. Any other questions you have? ESP भी मेरे सामने अगर वो बताना है तो 10 मिनट बता दूं. किसी को ESP देखना है? नहीं देखना, छोड़ो फिर छोड़ देते हैं ESP. ओके, अब क्या पढ़ना बताओ भाई. अभी आपका जो बचा हुआ है चलो वो शुरू करते हैं. नेक्स्ट बैचेस के जो अब बचे हुए हैं वी विल कंटिन्यू विद दैट. सो वी विल स्टार्ट विद शिप बिल्डिंग प्रैक्टिस नाउ. सो कई बार आता है मेक अ लेआउट ऑफ योर शिपयार्ड. तो शिपयार्ड में एक आपकी प्लेट असेंबली एरिया है जहां आपका स्टील्स आर सेक्शंस आर केप्ट स्टॉक्ड, ओपनली पड़ा रहता है. फिर उसके बाद मार्शलिंग एंड प्रिपरेशन का मतलब है उनकी सैंड ब्लास्टिंग, शॉर्ट ब्लास्टिंग होती है एंड दे आर मार्क्ड कि कौन सी प्लेट कहाँ होगी. देन मशीनिंग इज टेकिंग प्लेस फॉर वेल्डिंग. यूनिट असेंबली होती है, जोड़े जाते हैं and blocks are made, then the blocks are joined, and then you have this pipeline fitting here. Outfit shops are there for fitting. Then you launch that vessel in the basin and fit your radar, anchors and other gear. So that is your layout of your shipyard. ये डायग्राम बनाना है और एक्सप्लेनेशन अभी शुरू कर रहे हैं. So your shipyard will have a product, you will have a process, you will have facility and resource, you will have human labor there, space and layout and schedule for कैसे काम करना है. So the material requirement, so you will have the cutting there, sub assembly, middle assembly, heavy assembly, outfitting, painting, and the erection, pre-erection, erection, and then launching and all. So ये सारे requirements हैं. You can do your simulation on your computers for that. So suppose you are a customer and you're planning to purchase maybe a bulk carrier. So you will have a design there, and then according to your designs, the final design is selected as per your speed and consumption, fuel consumption, and then the plan and the expenses are calculated. Contract is signed between buyer and seller. Then you have the various vendors who supply. Warehouse में आएगा, sub assembly होगा, assembly होगा, and then launching of vessel will be there. तो उस डिटेल अभी कराएंगे. So this is your shipyard where your cutting, solvent degreasing, vessel cleaning, welding and painting, everything is done. Now this is that satellite photo of that Chinese shipyard there, and this is the floodable basin जिसमें ये launch करते हैं and then do the fittings. उसके बाद ये lock से बाहर निकलता है and then you have sea trials outside. So just move out from the lock. So here you have your side launching ramp there, floodable launch way, construction way, rail mounted environmental shelters, rail mounted shelters जहाँ ये सारा होता है. There's a construction hall, fabrication and assembly shops here. Block production area is in A, this one here. So it's shifted accordingly and then it is brought here and then launched into the basin. So steel plates and sections are stored in the stockyard and then they are fed into individual shot or grit blasting. So shots are basically steel balls. So at high velocity, they are blasted on the steel so that the rust is removed, and then by air it is cleaned, and then the suitable primer is applied, and then it's dried, and then the plates are marked and cut and bent as per the dimensions and shapes required. Then you have edge preparation for welding. Then your various steel parts in plates and sections are welded to form sub-assemblies, and then they are joined to form assemblies, and these assemblies are joined to form units. So sub-assembly is basically around 5 tons and it is 2D and made of several steel pieces, and these sub-assemblies will be joined to form a unit or an assembly, assembly which is about 20 tons and 3D shape. And these assemblies are joined to form units, which are complex shapes. So example of unit can be collision bulkhead, which can weigh over 100 tons. Then units are joined to form your ships. तो ये आपका शिप बिल्डिंग प्रोसेस आ गया, शिप ओनर्स रिक्वायरमेंट, प्रिलिमिनरी डिजाइन. तो ये भी फ्लो चार्ट बना सकते हो जो मैंने बताया था. एक तो ये बना सकते हो कि ये बना सकते हो. Either of that you can make. So ship owners requirement, preliminary design, concept design, basic design, detailed design. This I'll be explaining. Part fabrication, processing here, part assembly. And here you have pipe receiving, machinery, unit assembly. Then the erection here. So block assembly, painting. And then pre-erection, erection, launching. When you're launched in the basin, you're fitting outboard, and then it is brought by the locks outside, and then you have inclining experiment, then you have sea trials, and then the delivery. So here you have your drawing approval and receipt, material estimation, how much required, how much money, how much cost, material receipt inspection, surface preparation, priming, element cutting, sub-assembly, assembly, erection, and now the hull part, machinery, outfit, piping, electrical. Here you have dry survey of tanks. Here you have keel sighting, draft marking, principal dimensions to check. Machinery will be fitted, your outfitting, piping is fitted, electrical fittings, and then your tank testing, hose test, underwater fitting, outer hull blasting, accommodation works done, and after everything is done, then you have launching, vessel shifting and launching, inclining experiment, commissioning, sea trial, and delivery. So this is the entire shipbuilding process. Now basically this process is nowadays the future is simulation based, or presently you have your research data, database, lines plan, and CAD CAM and all. The future will be simulation based. So here you have steel cutting, block fabrication, and block assembly, launching, outfitting, commissioning, sea trial, and delivery. इसी तरह cutting, fabrication, assembly, blasting, painting, pre-erection, erection, and then your launching. So you have marine engineers, navigating officer, other staff working for that, and including naval architect and all. So the first process for shipbuilding is your global tender is there, and you're getting bids from various shipbuilding yards. And those are reputed yards. So the shipbuilders make a proposal based on the request of the client, and basis the cost, the time, the reputation of the yard, the client will give you the contract signed, and the proposal idea will be basically rough with the time required for shipbuilding, the cost involved, and the quality of that. So your specifications are discussed and agreed to, and once your proposal is accepted, the client and the shipbuilder will decide on the specifications, details, price, and then the agreement is signed with the legal formalities. Now, for your design and specifications, you have various types of design. First is your performance design, which is very important because basis the design, the performance of the ship can be anticipated. The main factor in performance design is the speed and the fuel consumption. जैसे आप कार खरीदते हो तो सबसे पहले आप देखते हो कि क्या स्पीड है और भाई माइलेज कितना देगी, बाद में उसके प्राइस की बात करेंगे. So before actually starting to make any design, the models जो हैं they are tested in a tank, and these models basically are having this the dimensions as per required basis on very small scale. तो इसी के basis पे आपका actual ship बनेगा, and this is subjected to the various stresses, and accordingly that testing is done. So the hull shape has to be made in that particular manner, otherwise it will not match your specifications. So initial formalities are done and your tank testing done, and the design phase will begin to take shape. So in the performance design, you have three designs. One is your basic design, second is your detailed design, and third is your production design. So production design is basically the actual design basis vis-a-vis your actual cutting will take place. Basic design is basically on a basic level with specification, and detail will be with your lines plan. Now this is a concept design which you find these kind of models in your shipping companies outside. This is basically a concept what kind of ship they wanted, and accordingly this model is tested in the tank. Now your various parameters are your input data given by the owner requirement for the hull, that is your dead weight, payload, what kind of speed you require, what maximum draft, initial arrangement, profit, how much the owner wants, what is the return of investment, maybe it is coming in 6 years, he's going to get the money back, or 7 years, including the scrap cost. Then the variation of design parameter means the hull form, your spaces, your outfitting, your structural arrangements, your piping, and the optimization criteria will be your performance efficiency indicators, your minimizing of environmental impact, because your environmental impact is very important nowadays as per NX6 SEEMP. That is important for your ships. So SEEMP is to be subjected to all these energy indicators and all are required. Then your minimizing of building and operation cost, maximization of investment profit, minimization of investment risk. The constraints can be your society, your MAPOL, your solars, market supply demand, cost, fuel, workmanship, and case dependent constraint. So all will give you a final output. Now what is the basic design? So the basic design, you're concerned about making a ship as per your requirements, as per the load carrying capacity, which is maybe bulk carrier of 50,000 tons. So what is the fuel, storage, consumption, stability? These all factors are linked to your ship speed. Now in detailed design, you have more details than your basic design. and its more practical implementation is understood here because your design has ensured that the ship will be close to the original specifications which were given in the contract. And if they cannot make as per the original design, so they have to inform the client then and there. Otherwise, the performance parameters can be compromised. The third phase in this performance design is your production design that goes into details and actual drawings of components are made. And you have to see that your major components in this shipbuilding yard may be taken from vendors outside. So your generators, bulbous boy and all maybe have to be got from outside rather than in the same yard. So that is the reason the order is made. This is the production design. So when the shipyard is ordering to various vendors, they have to decide that the material is got just in time and within the dates so that the deal will not jeopardize. So your plan is made. This is preparation for shipbuilding. So here you have to coordinate in a realistic manner so that your plan doesn't jeopardize and your goods basically arrive in timely phased manner. Now you start with the steel cutting now when your material is there. So your steel cutting is started and your steel plates are cut as per your plan and blueprint as per the design phase. And the steel plates are heated, bent, we made it curve and your shapes to be correct so that the dimensions do not jeopardize. Because if the dimensions are not correct as per design, then maybe the buyer might reject it. So once you have done your steel cutting and all the plate assembly is done, and the blocks are assembled and the manufacturer efficiency is to be maximized. So first is your small scale assembly, then mid scale assembly, and then large scale assembly, and then the units are formed and the units are then combined. So your vital stages of the shipbuilding is installation of rigging. Your assembled blocks are joined and huge blocks are made. Then your wires are installed and pipes are installed, and you have to see that your efficiency is correct. And these rigs are in place until the block is docked on the ground. Because if any accident takes place, then everything will be jeopardized. Mounting of blocks is important because there your cranes are important. They should not fall or crash. So the specification have to be met as per the design phase. So if you have to join the blocks, you have to see that the final product is same as per the basic and detailed design. Now when you've joined the ship and all, all set, your material is made, you have launched it to your basin. So the ship launch date is decided, and this dock is filled with water, and ship can float. And then you have to go from the dry dock to the dock to the sea for sea trials. And before that, you have inclining experiment. So this is airbag type of ship launching, where you have these bags filled with air for launching. These are for small craft. This is gravity type side launching, and this is your basin, the basin of the dock. This is launched here, and then your fitting is done once it is launched in the basin. These are all small boats which are launched by cranes, mechanical type. Now this is your floating dry dock, and your launching is done by this. These are the various types of launching. And then sea trial hota hai. Sea trial mein all your parameters, advanced transfer, stopping distance, and all everything is checked along with the speed. Your speed should be critical, should be actually as per your design, because this is the base of your agreement. That's the sea trial being done. Then your final delivery is done, and the ship will sail smoothly. So all your teamwork is required in this. So you have organization in shipyard, which is steel workers, welders, fitters, painters, riggers. So the management is headed by chairman, board of directors, and then various departments. And then your departments will be doing your planning, production, launching, and all. The construction is shipbuilder's responsibility, but your shipyards have to rely on your vendors for the various products. But then you have to see your production cost is kept low. So other design, ये सब basic design क्या है, that we'll be doing in the next class. So the basic design क्या है, concept design क्या है, preliminary design क्या है, contract design क्या है, this we'll be doing in your next class. अभी तो shipbuilding का yard and all we have done. Now the actual designs and all we'll do in the next class. कोई questions अभी April batch? कोई questions अभी बचा है? अभी हो गया आपका रिवीजन सारा? अब तो करा दिया ना अब तो? चलो फिर ब्रेक ले लेते हैं. ऑल विश यू ऑल द बेस्ट फॉर योर एग्जाम्स भाई. ठीक है, विश यू ऑल द बेस्ट.
Okay, sir.
ओके देन.